So we're going to express this number in scientific notation. So the number is 0.000355. And so the way this works is we're going to move the decimal place over until it comes right after the first non-zero number, which in this case is 3. And then we're going to rewrite the digits afterwards, the 3.55 times 10 to the 1, 2, 3, 4, negative 4, which will represent a small number because of the negative exponent. Now we're going to work the opposite way. We're going to take the number from scientific notation and express it in what's called standard notation. So we're going to do the opposite of what we just did. I'm going to take the decimal place and I'm going to move it 5 times to the left to get that really small number. And then I'm going to fill in the zeros. And then write the number all the way out. So it should be 0.0000998. So those were really small numbers with negative exponents, but now we're going to practice writing a larger number in scientific notation. So the number is 1492. So I'm going to move the decimal place over until the decimal place comes right after the first non-zero number, which is 1. I'm going to write out all of the significant digits, which we will talk about, times 10 to the positive 3, because I moved that decimal place over to the left, which indicates a larger number, which will be reflected by a positive exponent. The next thing we're going to do is practice counting significant digits. And so the important rule is that all non-zero numbers are significant. So in this case, 2, 1, 8, 2, 8, they're all non-zero numbers. So this is going to have 5 sig figs. So significant digits is sometimes called significant figures or sig figs. So it gets a little more complicated when we have zeros because not all zeros are significant. We have 3 types of zeros. We have zeros that are called leading, zeros that are called captured, and then we're going to have zeros which are called trailing, which is in the next one. So leading zeros are not significant. So the ones here in pink are not significant. Captured zeros are significant. And then we're going to see that trailing zeros are sometimes significant. So in this case, if I'm counting significant figures in my second one, the 5, and the 5 are all significant along with that one captured zero because it's between 2 non-zero numbers, which gives me an answer of 4. If I look at the next one, we know that the 5s are significant. The 0 that's in between the 5s is also captured and it's also significant. But in this case, the 0 underlined in purple is not significant because it is not captured and it's not following a decimal place. So if I did, let's say, have an answer or an option like this with a decimal place, also looks like a period, now this 0 becomes significant because it is exactly 55,050. The one that we see here on the left, could be a rounded answer. It could be 55,045. Rounded up, or it could be 55,054 rounded down. So there's some uncertainty associated with this answer because it could be rounded, whereas this is exactly, I have counted out 55,050. So in this case, this answer would have 5 sig figs. So you'll practice with these two. Then we're going to use our significant figures to do a little bit of math. And the rules for addition and subtraction are going to be the same, and the rules for multiplication and division are going to be the same. So we'll just practice the division and the addition. So when you're doing multiplication or division, you are going to count out how many significant figures are in each of the starting numbers. So in this case, 217 has 3 sig figs, 903 has 3 sig figs because that's a captured 0, so it's significant. This means that my final answer can only have 3 sig figs, and I may have to round in order to make that happen. So if I take 217 and divide it by 903, the answer that I'm going to get is probably not going to have exactly 3 sig figs, which in this case is correct. So I get 0.240310008. And so this has several sig figs. Now, in order to report my final answer in 3 sig figs, I first need to remember that the 0 in front of the decimal place is not significant because it's leading. So I'm going to take these first 3 numbers, and then I'm going to look at the 4th number, which is a 3, and decide, does it round up or round down? In this case, we should know that 3s do not round up. And so the final answer with 3 sig figs is 0.240. Just like before, the leading 0 here is not significant. This is a trailing 0 that follows after a decimal place, which makes it significant. The second one is an addition problem, and the way to do addition and subtraction problems is to line up the decimal places. So in this case, I'm going to add everything up just like I have always done. We're not going to change the way that you are doing your addition or subtraction. So once I add all of my numbers up, now I'm going to draw a line between the number that has the fewest decimal places. And in this case, 515 doesn't even have a decimal place, so I'm going to draw my line right here. If 515 had a decimal place, I would draw it after that decimal place. Now I'm going to look at the number on the right side of the line and decide, does it round up or round down the number on the left? And in this case, 9 rounds up, and so my final answer is 1,437. Okay, so very similar to how we've done math in the past. We're going to add everything up. We're just going to limit our final answer based on decimal places and not number of sig figs. So you can practice the other two. The one right here is reviewing metric prefixes, so make sure you know the metric prefixes. There's a really nice table in your PowerPoint as well as your textbook to help you work through those, and then you'll have some problems on sapling homework. This last one right here is a density question. So it says, what is the density of oxygen gas if we have this volume of sample and this mass of oxygen? And so the important thing is to remember that the relationship between density, mass, and volume is density is equal to mass divided by volume. The units can be varied. So in this case, I'm not going to worry so much about what units I use because it doesn't tell me to use specific units. So I'm going to just use the numbers as they are. So I'm going to take 21.7 grams and divide it by 15.0 liters. And the number I get is 1.44666 for all of time. Okay, because the 6's repeat. So the thing to remember is that now I need to express all of my final answers in sig figs. And so in this case, 21.7 has 3 sig figs. And 15.0, it's exactly 15.0. So that 0 following after the decimal place is a significant trailing 0, meaning my final answer can only have 3 sig figs. So 1.44, those are the first 3 numbers, and then I'm going to look at the 6 and decide, does it round up or round down the 4? And we should see that it's going to be 1.45, and then to keep using my units to be correct, I'm going to report this as 1.45 grams per liter.